Hello, welcome back to physics and number 9, projectile motion. Now, in physical science, we learnt or tried to learn how to do these sorts of motion where we throw something off the cliff with a horizontal velocity and then it impacts with the water or the ground, and we recognize that what this diagram is trying to show us is that the horizontal velocity remains constant because we're ignoring air resistance, and so there's no force to change the horizontal velocity. It is, however, the vertical motion or the vertical velocity that changes and increases exactly the same as if we had dropped and had just vertical motion. And so projectile motion is a combination of the horizontal motion and the vertical motion. And this diagram is trying to show that, if I draw it very carefully, let's just see, that the actual velocity is a combination of those two vectors. And the actual velocity changes direction as we combine. I'm a bit shaky. That's very shaky. Alright, but the actual velocity is changing as it falls because the vertical component is getting larger and larger, and so it's swinging around, and eventually, if this was the impact velocity, we'd have to work that out, and we'd have to work out that angle there, which is what students often have difficulty remembering. But let's go through a couple other examples. And again, this is just another diagram going from left to right this time, and what it's showing is if this was a time lapse, you can see that in terms of the distance between these lines, this distance represents how far it has traveled horizontally, and so we could draw this distance here like so, and between each time frame, which we're assuming to be equal, we are traveling the same distance. So all those blue double-ended arrows are the same size. However, it is traveling in the vertical, getting a larger component of displacement for each time interval because it's accelerating. And it's accelerating due to gravity. Alright. Another one. Here's an animation. Alright, now if I magically clip on this, here's two balls, one's undergoing vertical motion, one's undergoing projectile motion, and they hit the ground at the same time because they're both falling at the same rate. The only difference being the blue ball has a horizontal component because it travels one square every frame. And it does that, and it still hits the ground at the same time. Let's just do that again. Okay. So even though it's got a horizontal velocity, it's falling under the influence of gravity at the same rate. And you can replay that if you like. Now let's have a look at an example. A golf ball is thrown horizontally off a cliff with a velocity of 20 meters per second. Take 4 seconds to reach the ground. Calculate the height of the cliff, how far from the base of the cliff it will impact, and the impact velocity. Now, these sorts of questions, they can give you different pieces of information. In this case, we're given time, but sometimes they give you different stuff, but they always give you enough information to answer the question. Remember that. And so sometimes it's hidden. Let's have a look at what we're given. We're given the initial velocity. We're given the acceleration. Okay, we're not given it, we know it. This book again, this example, they're using 10, but we would use 9.81, and we're given time. So we have our three things, and once we get those three things in either the vertical or the horizontal, we can solve it. In this case, we're looking at the vertical, and so they just put the numbers in, being careful with their sign, and you get a minus displacement, which tells you that the height of the cliff is 80 meters because you're saying that the top of the cliff is your reference point. Now, how far away horizontally? So in the horizontal, you've got the initial velocity, you've got the acceleration, You've also got the final velocity, but that doesn't help you, and the time, so you can use s equals ut plus half at squared. This effectively becomes 0 because a is 0, and you get 80 meters. So it happens to land 80 meters away from the 80 meter cliff. Look at that. And finally, the impact velocity. You've got to sum the horizontal velocity, which remains constant, and the actual final vertical velocity. Okay, and so to work out the final vertical velocity, they said that u equals 0. They've got the time and the acceleration, so it's minus 40. So doing some vectors, you have your vertical, you have your horizontal, and therefore your impact velocity. And they're working out this angle because that's a convenient one to work out, because that will be the angle down from the horizontal. Okay, and that's a handy one to work out. And so just to work out this is the impact velocity, you just use Pythagoras, and then you can use sine, cos or tan to work out that angle. Yeah, not too hard, and hopefully you get, even if you didn't get these in physical science, with a bit of practice you should get them in physics. Now the ones we didn't do in physical science are these ones, where you project something at an angle and it lands at the same horizontal height. And so what happens is, this is a combination of constant horizontal velocity and the up and down motion that we did do in physical science. And so if you look at this, they've again drawn your arrows representing the vertical velocity and the horizontal velocity, and in terms of the vertical, as it goes up, the vertical motion is exactly the same as if it goes up and then comes back down. Alright, and that's what these vectors are representing. Okay, the velocity for an instant, it stops and then it accelerates at exactly the same rate as it was decelerating, which is minus 9.8 meters per second to minus 2. Alright, and what you should also say is that here, this is still VH, and this will be the same, but minus. And so if this was 10 meters per second, this would be minus 10 meters per second, because we're ignoring air resistance. And so the resultant velocity, so the velocity that you threw it with, u, is equal to v, but with a minus the equal but opposite vertical component. And I think I say that in a dot point in a sec. Alright, let's have a look. Now the thing here is that you've also got to work out your components, because more than likely you'll be just told that the object is has an initial velocity of 10 meters per second at 45 degrees to the horizontal. And so to separate your horizontal and vertical components, you've got to separate your horizontal and vertical components in terms of the initial velocity. And this should in reality be a u, and this should be a u. Alright, because that's our initial velocity, u. And so the first thing you do in these sorts of questions is you work out your initial horizontal and your initial vertical. And then you start using those. And you try not to mix up your horizontal and your vertical parameters, which I know it's sometimes hard to do, not mix them up, but if you're careful, you won't mix them up. And when you do your impact velocity, there you go. We've done that before. That's just recombining your vertical and your horizontal into a final velocity. And this little animation, a couple of things to note here. The purple line represents the velocity, the orange line is the vertical velocity, and the yellow is the horizontal velocity. So if we just first of all look at what happens to the velocity, it's going up, it's now okay, and then it's pointing down, and that velocity is a reflection of the initial velocity. Now if we do that again, but look at the orange, again exactly what we've been taught before, is the vertical velocity changes direction And if we do that again with the horizontal, nothing happens to the horizontal. So in terms of their labeling in this diagram is velocity x, where x in maths would be the horizontal axis. So this is the horizontal velocity, is constant, whereas Vy is the vertical velocity. You're welcome to use this nomenclature if you want. It's up to you. And it starts out as being positive, if we look at it, and then decreases at a constant rate, and then starts becoming negative and increases. And the slope of this line would correspond to the acceleration. And in this case, it's gravity. So it would be minus 9.8 meters per second. Minus 2, sorry. Right, let's do a quick example of something we haven't done before, which is a ramp. So here are stunt drivers driving a car over a river. It's travelling up a ramp. You've got the angle of 45 degrees. It's leaving the ramp at 22 meters per second. It's 50 meters wide. Is it going to make it? So it's going to land at the same horizontal height. Is it going to make it? So what is the information we know? If we look at it, let's get this happening here. Let's go blue. Alright, in terms of vertical and horizontal, okay, we should get into the practice of U, V, A, S and T, identifying what we're given and remembering that the magic number is of course 3. And so if we look at this question, what are we given? Okay, we're given a velocity, so from that we can work out the initial vertical velocity. Okay, and from this we should be able to work out the initial horizontal velocity. Now the final horizontal velocity will be the same, so we know that. We know the acceleration, which is minus 9.8 meters per second to the minus 2. We know in the horizontal it's 0. Okay, we know that in the horizontal it's got to travel 50 meters. Okay, and if we looked at half the flight, so if we only looked at half the vertical, we could say that that's 0, and therefore we could get T here, and recognizing that if it's only looking at half the flight, we'd times it by 2, and that would give us the time of the complete flight. And so we're not interested in how high it goes. We could be asked though, but we could work it out. And that of course goes across to there. So they're all the things that we know, and it's good practice before you even attempt the question of writing down and making sure what you know and making sure you pick everything, because it will make doing questions easier in the future. Right, let's have a look at how they do it. So assume up is positive and down is negative. That's pretty standard. And here they are, they work out their two components. The vertical component is 14 and the horizontal is 17. Okay, now to calculate the range of the car, they need to look at the horizontal motion, but before they look at the horizontal motion, they'll work in the vertical motion to calculate how long it is in the air, and therefore they can then calculate the range. So in the vertical, you look at half the flight, which is what we did, using the final velocity is 0, because that's the high point. Put it into V equals U plus AT, they get an answer of 1.4 seconds, and that's only for half the flight, so they times it by 2. That gives us the time. We can then bring that over here. We've got the time, we've got the initial velocity, we've got the acceleration. We can just use S equals ut, or we could have used the equations of motion, and we would have got the same answer. And so, did it make it? No, it didn't make it. Oh no, that's no good. Maybe they should have made it so it did make it. Rightio, let's move on. So, some tips in doing these more complicated calculations. it helps to draw a diagram. It really does. If you can't visualize the question, you can't assign information, and you have difficulty working out what you're actually trying to solve. Always separate the motion into vertical and horizontal components, and don't mix them. The only thing that you can mix is the time, and you still have to be quite careful with that. Remember to resolve the initial velocity into its components if necessary. A lot of students miss that step and just go off using the velocity and then wonder why they get the wrong answer. The time in flight is the link between the separate vertical and horizontal components, as we've said before. At the end of any calculation, this is quite important, check to see if the quantities you have calculated are reasonable. Okay, if you're talking about a car jumping over a river and you get an answer of 250,000 meters, that tells you something's wrong. And that goes with all physics questions. If you get later on, most of you will probably know that the speed of light is a constant and you can't go faster than the speed of light. But if you do a calculation and you get something moving faster than the speed of light, it's obviously wrong. So try and work out if your answer is reasonable or not. Let's do another example quickly. A mortar is a weapon that used by the Defence Forces. It fires a shell at 200 meters per second at an angle of 40. Calculate. Look at all these things that we can calculate from that little bit of information. Sometimes they ask you all these things, sometimes they don't ask you all these things, but you need to be able to do it given enough information. And so in terms of this, again they're using -10, and we can live with that. So first of all, they separate it into the vertical and horizontal velocities. Don't forget that, and being careful with your sign as well. Up is positive, horizontal doesn't have a sign because it doesn't change. So the maximum height is when the final velocity or the vertical velocity is 0, and so they use v squared equals u squared plus 2as, and they rearrange it and then they put the numbers in, being careful with the signs and being careful with their brackets and calculations, and they get the answer. So it goes pretty high. And see the time of flight. Time of flight is calculated. Now there's a variety of ways of doing it in this question. You can calculate the time of flight by looking at the time it takes to reach the maximum height and doubling it. That's certainly what I would consider to be the easiest method. If you're confident in doing that, you can have a go at the second way, and that is determining the time taken until the final velocity is equal and opposite to the initial vertical velocity. And finally, there's a third way, which I generally don't recommend, but you can have a go at it, is you work it out. The time of flight can be calculated by when the displacement is equal to 0 again. So you say s equals 0. Let's have a look at how they do it. First one we're familiar with, we're halving it, and so v is 0, so we get a 0 there. We get 12.9, so we times it by 2. And we get that. The second technique was using the final vertical velocity is equal or opposite to the initial vertical velocity. And so the initial vertical velocity was plus 129. The final velocity is going to be minus 129. And we've got our rate of acceleration. So you put those numbers in, being careful with these signs. And this is where students undo themselves. They're not very good at these signs, but if you're doing this technique and you get a minus answer, you're doing something wrong. Okay, so you work out the answer straight off. And the second technique is you put the numbers in and you get this equation and you simplify it down and you do this, but I generally don't recommend using the third technique. And the horizontal range is equal to the horizontal component of the initial velocity times by the time of flight, because it's constant velocity. Now you can use the equations of motion where a equals 0, and I recommend you use that. They're using the constant velocity equation s equals v times t to calculate it just as well. And the impact velocity, you can go through and work out, draw the triangle and have your vertical velocity and your horizontal velocity, and then use Pythagoras to work out the hypotenuse, and then use sine, cos and tan to work out the angle. Or you can just say, because it's landing at the same height, the impact velocity will have the same magnitude as the initial velocity, but will be directed downward, not up. The angle of impact will be the same as the angle of elevation, but downwards. Okay, and so they say the impact velocity is 20 meters per second, 200 meters per second, at an angle 40 degrees down from the horizontal, I would say. Alright, that was quite a lot. Guess what? We haven't finished. We've got another example to do, but let's put it in another video. So, cheerio!